Welcome to Software Heresy video number 2. If you have not watched the intro video, I recommend you go and watch that first before watching this video. Now in this video, we're going to be talking about NoTDD, why I think you shouldn't do TDD. I'll use my standard warning for this video. Heresy can be a bit uncomfortable, or sometimes it can be insulting. This video in particular, if you aren't at least a little bit insulted by the end, I do not think I've accomplished what I'm planning to accomplish. But please try not to take it personally. I do have a goal in taking this approach. I simply don't know how to talk about these topics without being a little bit insulting. Now, TDD is a really interesting thing, and something that's very interesting about TDD is the differences in opinion that we find about it. So I went out and just did some searching and found a bunch of articles on TDD. And here's what I found. Everything from TDD is the best thing that has happened to software design to test-driven development is done, or test-driven development is not for me. So we do find some opinions in the middle, but mostly we find people polarized towards either the TDD is good camp or the TDD just doesn't work camp. And I've always found this interesting, as this mirrors the results that I've seen when I've tried to teach TDD in the groups that I've been in. And I found some people have turned into advocates and really liked it, and then I found other people just said this really doesn't work. And that's seemed to happen even when we did things, what would be called the right way. If we do introduce TDD, doing katas and doing pairing and all the ways that you're supposed to do to teach it the best. And even after that, we got so the whole team could do TDD and the katas, but we still saw this big bifurcation into two groups when people tried to do it in the real world, in our real code. And I've thought about this and looked at a bunch of things, and I think I understand better about what's going on. So that's what we're going to talk about. Now, because this is a TDD talk, I'm required to put up a graphic like this, that is the TDD test flow. And so we start by writing a test that fails, our tests go red, we make the code work, our tests go green, and then we refactor. I find it really curious that this says eliminate redundancy, as if that is the only thing that we do in refactoring. But this is the flow, so red, green, and refactor. And I thought it would also be useful to have kind of a textbook definition of what TDD was for terms of our discussion. So I went out and I looked at a few, and I found this one by Martin Fowler. And this says, refactoring is a controlled technique for improving the design of an existing code base. Its essence is applying a series of small behavior-preserving transformations, each of which too small to be worth doing. Now, when I went out and found this quote, you have no idea how happy it made me, because I'm doing a talk on heresy, and I get to say that I think Martin Fowler is just wrong about this. I don't think this is the essence of refactoring at all. Here's my definition. Refactoring is a controlled technique for improving the design of an existing code base in small steps. Its essence is understanding the design feedback the code is giving you and knowing techniques to address that feedback effectively. And the big difference here is, I think the essence is understanding what the code tells you and knowing how to improve it. Now, I will point out here that if you are Martin Fowler, you know how to do both of those things very, very well. And perhaps the definition given works really well for him, but I don't think it works well in general. So I think you have to understand the design feedback the code is giving you, and you have to know techniques to address that feedback effectively. But, and if you haven't watched the first video, go back and watch it and come back, because this won't make sense. Remember this chart from the first video. Let's say that we are doing refactoring, we are doing TDD, and we're trying to either write good tests or do refactoring. And we happen to be in these two quartiles. How good are we going to be at understanding the design feedback and knowing techniques to address that feedback effectively? Well, by definition, if we're in the bottom two quartiles, we're worse than average at doing this. So we're not well equipped to do this, but we think that we're up here in doing this. We think we're good at seeing what's wrong with code, and we think we're good at doing refactoring and making it better. What does that mean? Well, that means when we take these bottom two quartiles and we apply them out to this, what do we find? Well, first we find that writing a test that fails can be hard. Now, I'm going to talk about mocks in a future video, but in general, what we would like to see here is we make the code, we refactor the code so that we can actually write a test that fails simply. But in those bottom two quartiles, we're not very equipped at A, understanding what issues there are there, and B, actually changing the code to make it easy to write tests. Now, to be fair here, in most code bases, the code base is actively anti-test. It really does not want you to write tests. And therefore, this is a hard problem to solve. It's a hard task to do. I sometimes refer to this as a graduate level problem, and we're trying to address that with only undergrad skills. Worse, after we write the tests, the refactoring part requires that we see what the code is telling us, figure out how we could improve it, and actually make those changes. I'm going to argue not only in the bottom two quartiles, but probably in the third quartile as well, we don't have a lot of sensitivity to this. And therefore, the test-driven development refactor phase just comes into no op. So simply nothing happens. So instead of having this nice circle where if you're Martin Fowler, this is great. You write a test that fails, and then you come around and you say, oh, there's obviously something here I want to fix. I'm going to go fix it. And then I have great code, and I just keep doing these small steps, and I have great code. Wonderful if you're Martin Fowler. So that leaves us with a bit of a problem, or a bit of a dilemma. We need to choose between traditional upfront design and TDD. And here's how I see the choice lay itself out. For upfront design, most developers know how to do this to some extent. They've been exposed to some idea of doing real design. They may not be very good at it, but they have some ability to do it. And more important, we can actually ask them to do it, and we can discuss what their design is and discuss whether there are better opportunities or better alternatives to that design. And better, we could even do the whole design as a group. So instead of relying on the skills of just one person, or two, if you'd happen to pair, we can rely on a broader group of skills. So most developers can kind of do this. What about TDD? Well, as I said, most developers are not skilled at identifying refactoring opportunities. You have to see something and know where you want to take the code. And both of those are skills that you need to learn. Because of that, and because we see no ops in both the refactoring parts, that results in tests that are highly complex. Mostly because we didn't get that improvement in refactoring that we hoped for. So we're just kind of, instead of doing upfront design, we're just kind of doing whatever makes sense at that point design. So tests are highly complex. Test maintenance cost is high. Interestingly, if you go and you look at what the people who say TDD doesn't work well, what are they saying about it? They're saying the tests are highly complex and test maintenance cost is too high. So what does this all mean? Well, I actually think unless you have developers who are pretty good at refactoring, you shouldn't do TDD. Or at least you shouldn't do TDD on most of your code base, because you're just not going to end up with good results. Now, if you have the luxury of building new stuff where you're starting out clean, then TDD may be a better option, but you will still likely reach a point where the complexity of the code exceeds the ability of your developers to do TDD effectively, to do the refactoring effectively. So what do I think? Well, I think instead of teaching your group to do TDD, you should use that time to teach them how to refactor, or learn together how to refactor, and transitively learn what good design is. Another way of putting this is, I think refactoring is the much more fundamental skill than TDD is. If you know how to refactor well, then you can apply that in a broad set of situations. You can do it in TDD, and you can do it to take your crappy code base that is hard to test and make it easier to test, or just make it better in general. Without those skills, TDD doesn't really give you the benefit that you want. So that's the end of my heresy about TDD. I hope to see you back for the next video when I'll commit heresy of a different form. Thank you.